Today's intro is brought to you by the Canadian rock band Rush.
In the constellations of Cygnus, there lurks a mysterious invisible force. The black hole of Cygnus X1.
Now, if you don't know Rush, well, first of all, you're really missing out, but in this song, a space explorer travels to a black hole called Cygnus X1 and gets sucked in. Cygnus X1 was the first black hole ever discovered. Black holes have long been a source of inspiration for science fiction, and their official discovery made scientists like Stephen Hawking household names. Kind of impressive for something that started out as a mathematical curiosity. But what are black holes, and how does their existence make any sense? Well, that is our topic for today's show.
We choose to go to the moon.
The rum-tum-tugger is a curious cat.
100 billion other galaxies.
Right now, you like me.
Welcome to 5 Minute Trivia, where we're making the world smarter 5 minutes at a time. I'm your host, R.M. Zuberi. Today's show is the first of a two-parter on the weirdness that happens when stars stop being stars. In 1905, a clerk working in the Swiss Patent Office had some thoughts. In between approving patents for electric typewriters and gravel sorting machines, he published scientific papers on motion, electricity, and, something he called relativity. The clerk's name was Albert Einstein. Now, there is a lot to relativity and a lot more than E equals mc squared, but we'll keep it simple. Einstein's equations establish that space isn't just space. Like, it's not empty nothingness. It's an actual fabric in which matter and energy are embedded, and that fabric of space is warped by the objects in it. And the more massive the object, the more the space is warped. Like, imagine dropping a bowling ball on a mattress. It deforms the mattress, and things that are near it will fall towards it. That's how gravity works. The more massive the object, the more space is deformed, and the more gravity it has. In 1928, a 19-year-old student named Subramanian Chandrasekhar applied that idea to stars. Stars are basically massive hydrogen bombs with a lot of gravity. They have so much gravity that they need to keep exploding outwards so they don't collapse under the force of their own internal gravity. But stars eventually run out of fuel, stop exploding, and start collapsing. That collapse can be violent and energetic enough that the star has a rebound explosion called a supernova. Not all stars go supernova, but whether they do or not, the core of the star keeps collapsing and getting denser. Now, Chandrasekhar theorized that these massive stars will collapse so much that they'll end up as these small, super dense wells of intense gravitational force. Like, just a spoonful would have the mass and gravity of a mountain range. Stephen Hawking and Roger Penrose went even further and predicted that stars could theoretically collapse so hard that they could end up as a single tiny little point with all the mass and gravity of a star. They called that a singularity. The star around that singularity, that tiny massive point, becomes a black hole because the gravity is so intense that even light can't escape. Now, all of these theories are based on putting extreme numbers into equations thought up by a patent clerk. There's nothing real yet. We need something real. We need
The black hole of Cygnus X1.
In 1971, astronomers found X-rays coming from a binary star system in the Cygnus constellation. A binary star is where two stars orbit around a common point, but there was only one visible star in this one. Where the other one should have been was an intense source of galactic X-rays. Hawking worked out that this was a black hole that was pulling matter away from the main star and heating it into X-rays. More study confirmed that it was a black hole that we now call Cygnus X1. The boundary of a black hole is called its event horizon. The event horizon is the point of no return. When something passes the event horizon, it enters the black hole and crosses into that infinitely small, infinitely dense point called the singularity. Gravity there is so intense that not even light can get out. Why is that? Well, there's a two-word explanation.
Mass hysteria!
No, not those two words. The words are escape velocity. You see, to escape Earth's gravity, a rocket has to hit 11 kilometers a second, which is about 25,000 miles an hour. In the sun's gravity, that escape velocity jumps up to 600 kilometers a second, or about 1.3 million miles an hour. Now, a black hole with its nearly infinite gravity has an escape velocity that's greater than the speed of light. Einstein's relativity established that nothing travels faster than the speed of light, including light. So if light can't escape, it can't reach your eyes, and all you see is blackness. In other words, that space explorer from the Rush song was doomed. Now, not all stars collapse into black holes when they die. That is what we'll take on in our next show. That's our time for this week. Tune in next time for the conclusion, and thanks for listening.